Greetings to our lecturer, T.S. Muhammad Zakaria bin Muhammad Nasir, and our fellow friends. We are from Faculty of Mechanical Technology and Engineering. Course code is BMKA 4233, Vehicle Suspension System. This is our project assignment presentation. Our team contains 5 hours. Shalvin Anaki Marimutu, Yogan Analaki T Marimutu, Savinash Analaki Mohan, Harinath Analaki Gautaman, and also Mahadevan Analaki Sukumaran. This is our company profile, and our company name is Lia Motion EV. Lia Motion EV is an automotive engineering and technology company focused on the analysis, development, and also optimization of suspension system for electric vehicles. The company specifies in improving ride comfort, handling stability, and also overall vehicle dynamic performance for modern EV platforms. By applying principles of suspension kinetic, vehicle dynamic, and vibration analysis, Lia Motion EV aims to address the unique challenges introduced by electric vehicle architectures, including high battery mass, altered load distribution, and also increased expectations for passenger comfort. These are our company's mission and vision, focusing on precision, engineering, and technical accuracy. Lia Motion EV aims to contribute reliability and efficient suspension concept that support the performance and safety requires for the future EV platform. Through continuous learning, research engagement, and technical innovation, Lia Motion EV seeks to play a role in shaping suspension solutions that improve comfort, control, and overall driving quality in next generation EV cars.
Okay, my name is Harina Analaki Kautaman. I'm going to present about the company profile and manufacturing. There are three company is in the assignment: Tesla, BMW, and Hyundai. Today I'm going to tell about the Tesla. The vehicle around the detected electric performs along the optimal weight distribution and the low center of gravity due to the placement of battery packs the vehicle flow. This design is a philosophy of a direct influence of Tesla suspension system choice, which aim to support handling with the acceptable ride comfort. Moreover, Tesla focus on the precious steering response, stability, high speed handling, and effective packing while maintaining reasonable manufacturing complex suspension turning in the Tesla vehicle is generally oriented towards film damping a characteristic support and the brand's performs orientedly driving experience and dynamic stability under the rapid accelerations and the regenerative braking condition. And the BMW. This is BMW i3 where the suspension designs play a critical role in deliver response and predictable vehicle dynamic. Moreover, the rear-mounting lightweight structure, the ability of short wheel bincer is the and the suspension stability priorities, king accuracy and controlling the body motion and balance between ride and comfort performance. These are on the BMW i3 and the Tesla. Okay, company profile manufactured about the Hyundai Motor Company. The Hyundai a five presenting company model EV design the philosophy. Hyundai the emphasis of user comfort, riding, retirement, and everyday usable in its vehicle suspension. Hyundai suspension turning the priority smoother rider characteristic, effective road associations, and the stability handle suitable for a family-oriented use. The company approach reflects strong empathy on the delivery, comfort, and reliable vehicle design that meets need of a broad range of users. Okay, the introduction of this factory introduction new challenge for the suspension design as the suspension must be the simulators of management high static load, dynamic weight transfer, and the stricter noise, vibration, and harshness NVH requirements. As a result, EV suspension system requires a careful optimization to the balance comfort and handling perform durability and energy effect. Managing manufacturing increase the adopt independent suspension layout and advance damping the strategies to the advance address these challenges. By examining the in-front and rear suspension conflicts, the tire sizes, strategy, and engineering behind each design, this is how the suspension system makes a specific vehicle purpose and objective.
Hi everyone, my name is Sharin Aliki Marimutu. Here I'm going to continue about the methodology. So the specification sheets, official engineering documentation and press releases and original equipment manufacture, it is OEM, support materials related to suspension configuration and approved wheel and tire specification. These sources provide reliable and consistent technical information necessary for accurate comparison of suspension layout and design parameters. Impact of battery mass distribution on ride comfort and handling performance. These academic sources were used to contextualize manufacturer suspension design and choices and to explain emerging trends in EV suspension developments. This approach will be enable a scientific evaluation of suspension system, design rationales across different EV market segments to maintaining the consistency with real-world engineering practice. As for task A, here is a general literature review for Journal 1, some of the brief critiques and technical evaluation. As for merits of the work, it provides a realistic full vehicle dynamic model suitable for modern EV and EV platforms. So the findings go to directly to support suspension design used in vehicles such as the Tesla Model S and Hyundai Ioniq 5, which rely on McPherson front and multi-link rear configuration. It also demonstrates that carefully parameter optimization can also significantly improve ride comfort without increasing the system cost. As for limitation and unaddressed aspects, the experimental validation is not included, and the influence of tire stiffness and wheel size is not examined in detail also. As for advanced adaptive damping technologies are not explored. So overall assessment, this journal provides a strong theoretical foundation for suspension tuning in battery electrical vehicles. Its conclusions align well with the suspension strategies adopted in the Tesla Model 3 and Hyundai Ioniq 5, making it highly relevant to this study. So it also for the journal too, it also have strong relevance to compact EVs such as the BMW i3. So the merit of the work will highlight the interaction between tire size, suspension, geometry and efficiency. It also provides clear engineering justification for the widespread use of multi-link rear suspension in modern EVs. Limitation and unaddressed aspect. This study does not consider adaptive or semi-active suspension system. The ride comfort assessment is limited to simulation-based metric, and cost analysis is not included. So these are the limitation and unaddressed aspect. As for Journal 2 overall assessment, this study offers valuable insight into suspensions, architecture selection for compact electric vehicles. Its findings strongly support the suspension and tire design philosophy adopted in the BMW i3 and complement the leader EV suspension and prevented in these things. Thank you so much.
A very good morning to my respected lecturer. My name is Yogan, son of T. Marimuthu. And the tracking number is B132334. The above slide shows the data compression and analysis. First model is Tesla Model 3. And the front suspension uses Mac Tensor Strap. The rear multi-link. Springs uses coil plus hydraulic dampers. And the designs focus on performance and efficiency. Tires is a size 235/45 and rim size is 18. The second model is BMW i3. The front suspension uses Mac Presence Start. The rear suspension uses 5 link and the spring uses coil plus hydraulic dampers. Tires which is 155/70 rim size 19 and another size is 175/60 rim size 19. And the design focus on efficiency and urban mobility. And the third model is Hyundai Ioniq 5. The front suspension uses Mac Presence Strap. The rear suspension uses multi-link. Spring uses coil plus hydraulic dampers. The tire size is 235/55, rim size is 19. And the designs focus on comfort and versatility. This slide shows task C, which is technical report and lab sheet. The first test one, road condition adaptation test. Objective is to evaluate suspension performance under different road surface conditions, including smooth and uneven terrain. An expected result. The suspension is expected to adjust damping force in real time, reducing body acceleration and improving ride comfort. Test 2 is driver's behavior and adaptation test. The objective is to assess suspension response under varying driving behaviors such as gentle cruising and aggressive maneuvers. The expected result was the system should apply softer damping during normal driving and increase damping during aggressive driving to enhance stability. The test 3 is long-term performance test, which is objective to evaluate the long-term performance and durability of the suspension system over extended usage. Third is expected result. The suspension system should maintain consistent performance with minimal degradation, demonstrating suitability for long-term operation. Now I would like to share about our team members and their responsibilities. First, our team leader, which is Sharvin Ananaki Marimuthu, and his role is for project coordination. His responsibility is to oversee project progress. Second is technical lead, which is me, Yogan Analaki T. Marimuthu. My role is suspension design and my responsibility is to ensure engineering accuracy. Third is testing engineer, which is Savinash Analaki Mohan. His role is system testing and responsibility is to conduct performance tests. Fourth is cost analysis, which is Harinath Analaki Gautaman, and his role in this is budget planning and responsibility is to estimate system cost. Last, which is documentation lead, which is led by Mahadevan Analaki Sugumaran, and his role is reporting and responsibility is to prepare final report.
Task C, based on the technical report and lab sheet. The table 2 shows the cost estimated table. First, the semi-active dampers, sensor and ECU will cost 15,000 to 25,000, and the installation and calibration will cost 4,000 to 6,000, and total estimate cost is 19,000 to 31,000. The proposed semi-active suspension system offers a practical and effective solution for improving electric vehicle ride comfort and handling performance. By adapting damper characteristics to real-time driving conditions, the system addresses EV-specific challenge while maintaining reasonable cost and complexity. This solution demonstrates a strong potential for future electric vehicle application.